Good afternoon, everyone. Hope you're having a great time at PDC. This thing is hiding me here. I'll stand and talk here. So thank you for coming to this session. I remember some of you from visiting our booth earlier today and having talked to you about device development scenarios over the last 2 days. It's been fun for me, at least, I can say for sure. So today, Barry and I are going to talk about the emulation technologies. Okay, that's primarily what we are going to focus on. But in that process, I'm also going to spend some time talking about getting you started with mobile development. So let me first introduce Barry to you. Barry is right here. Barry has spent close to 15 years at Microsoft now. And his first project, if he remembers correctly, was the compiler for DOS. Yep. Yeah. And this was Visual Basic for DOS, 1.0. That's what he worked on. And he's worked on many emulation technologies since then, including the WoW64 subsystem inside of Windows. And currently, he's working as an architect in our team, and he's the one who's actually been the dev lead for the device emulator that we're going to showcase today. And me, I'm Amit Chopra. I'm also program manager with the Visual Studio for Devices team. And I've worn actually many hats in the last 3 years that I've been with this group, being the community evangelist for the group, doing setup-related work, being the release manager, and most recently, I'm actually working on the next version of the managed IDE for the next upcoming release of Visual Studio 2000, whatever name we decide for that. So this talk, as I mentioned, is all about the emulation technologies. But the two questions that I want to also answer before we get into that is the two questions I've heard the most. People came to me and said, I have no idea how to do device development. I've never done device programming before. So just help me get started. Give me a quick 2-minute intro maybe to get started on device development. So I'll be covering that. And we'll also tell you that if you have no device to program, you can still be very productive and successful using our new technologies. So that's question one. The other question typically comes from people, and a lot of you I know I met with, who have already used EVC, that is Embedded Visual C, that was our native development for devices, and Visual Studio 2003. And your question is, okay, show me what's cool and exciting about this new Visual Studio 2005. So that's pretty much how we're going to take this session through, of me spending the first few minutes getting people up to speed so that you understand about device development, and then we'll do a deep dive into the emulation technologies. So that's pretty much what the agenda slide is, and we'll not waste much time, and I'll switch over to my demo machine. So that's Visual Studio, and everybody got Visual Studio in their PDC good CD. I haven't seen one of those, but I assume you got what's called the release candidate. And release candidate is pretty much everything you need to get started with device development. So if you do file new project, you will find that very prominently we'll have solutions or templates that are available for doing device development. So you can choose your favorite language. So if you see right here, you have Visual C. That's what my profile was set for. And you also can do programming in Visual Basic, as well as you have support for device development in Visual C++. So you can pick and choose whatever language you are most familiar with. There are two decision points that you will have to take. You'll have to first decide, let's say, what language I'm going to program. So let's say you picked Visual Basic. The next decision you're trying to figure out is what device am I going to program against? Is it going to be a Pocket PC 2003, a smartphone? Is it just going to be a standard WinCE device? Or am I going to develop for the new Windows Mobile 5.0 Pocket PCs and smartphones? And once you say, take a decision that, hey, I only have a Pocket PC 2003 device, you make another decision of, should I go against Compact Framework 1.0 or 2.0? Compact Framework 1.0 ships with most devices in ROM, and 2.0 can be installed side by side at the same time. And certainly 2.0 has more advantages of using that. But let's say we get started just with the device application, which is the 1.0 version of Pocket PC. So this is a cool new designer. This is the Forms Designer solution that we have for device developers. You can see this literally looks like you're developing on a device. That's a significant enhancement that we have made from the previous release of the product. In terms of doing your general programming, it's not any different. You took a button from the toolbox, put it on the form, you can resize it, you have the property grid, You can write your code behind it as well. I'll do my favorite. Message box. Not any different from doing device development. So this is one of the things I wanted to communicate to people who are like trying to understand how do we get started with device development. It's not any different. Go start Visual Studio, find the device project, and you are up and running in no time. This is my 30 seconds to get you started into becoming a device developer. So this is what we just completed. We completed a very simple application that's using Compact Framework 1.0 and will work on a Pocket PC 2003. How many of you here got the new device as part of the giveaway? A couple of you. So that's actually running Pocket PC 5.0 or Windows Mobile 5.0 for Pocket PC. And if you have created this application, what you can then go and do is say, I want to now change the platform. I no longer want to use this on Pocket PC 2003. Let's change that to Pocket PC 2005. And what Visual Studio will do is reopen your project and will have notion about what kind of a new device you have, what specific features are available. So once you have selected Windows Mobile 5.0, you have now access to some of the new managed libraries that exist inside of the Windows Mobile 5.0 platform. So that's one way of moving your projects from Pocket PC 2003 to Windows Mobile 5.0. What you can also do is upgrade your project. So what does upgrade actually do? So currently this project is targeting Compact Framework version 1.0. But once you've created this, you can take that whole project and say, no, I actually want to use Compact Framework version 2 because I'll find new controls, I'll have better memory management, more performance that is available on the runtime. And you can select and convert your project at, again, a single click of a button. So nothing visible changes here, but if you have been noticing very carefully, a bunch of new controls have been added. Look at the web browser control, a tree view control, a link label control. So all these are new capabilities of Compact Framework 2.0, which are now available to you. We also have, once you select this control, the capability of being able to dock it. That's a new feature in Compact Framework 2.0. What this does is take a control and joins it to one part of your form. Now, where do you think this is going to be useful? This will really be useful because today the devices are being done in such a way that people can just at a click of a button change the orientation from making it portrait to landscape and vice versa. It becomes very important for you as a device developer to be agnostic and aware of these facts that somebody could just on the fly change my application. How is it going to look? So what you can also do here is right inside your design time, you can do the rotation of the screens. You don't even have to deploy your application, but you can, as you're building it, understand and see how this thing is going to look like when it gets deployed on the user's machine. Let's rotate this back. We also have a concept of skins. So let's select the form. Actually, a better word for that is concept of form factors. Now, when you look at different devices, you'll find that somebody has a device that has a square screen, somebody has a device that has a VGA screen, somebody has a regular Pocket PC size screen. So what you can do is also choose a form factor for your device. So this one is now a square screen. So you can actually see right at design time how your application is going to look like. So we provide support for form factors as well. There's something else you can do which is very interesting. You started with a Pocket PC 2003 application, converted that to a Pocket PC Windows Mobile 5.0 application. How about converting that to a smartphone application now? Yes, that's possible too. Go and change the platform and change that to a smartphone application and see what happens now. It's a smartphone application. But did you notice something interesting that happened right on top of the screen? It says unsupported control. And that's something very interesting. A lot of people find it very interesting. A smartphone has no concept of a button on it. You cannot put really a button and have any UI that actually goes and clicks on that. So our platform verification tasks are aware of this when you select different platforms and tell you, hey, you're using an unsupported control. But then what do you do with it? Well, we provide you with IntelliSense that says, you can actually convert it to a text box, or you can convert that to a menu item. You convert that to a menu item, it takes your button, translates that to a menu item. Let's see what happened to the code we had written. It stays. It is all there right next to that. So, thank you. So that got you started in 30 seconds. And also I showed you some of the new features that if you had been using VS 2003, you'll find these as fairly significant differences between the two products. The next thing that I'm going to show you is a very interesting application. A lot of device developers run into this scenario very often. Your goal is to write an application that works differently when it is actually connected, which means it's cradled to your PC, and when it's actually not cradled to your PC. Think of it as making an application that has to test connectivity or synchronization of data. So we're going to do two things here. One is we're going to try and write this application and see how quickly we can write this because of some features which are available in Windows Mobile 5.0. And then we're going to show you how with the new emulation technology, you don't even need a device to test the whole cradling and uncradling scenario that I'm talking about. This is something people find very amazing because when you talk of testing an app that requires physical connectivity and non-connectivity, people think of using a real device. But in this case, we'll show you how the new emulation technologies will completely take that need away of having a device to test even a complex scenario like this one. So let me show you what I have here on this form. This is just one label which has a string right now which says status. There's nothing else. And if we switch to view code, show you a couple of things that I've already done. I've added a reference to the Microsoft Windows Mobile library. This is a part of the Windows Mobile 5.0 SDK. This doesn't come as part of Visual Studio. And if you need one of those, they are available at the Windows Mobile booth, or you can take them from me later today at Ask the Experts. And they're also available as free download from the web. These have a lot of capabilities. Now, there are a lot of managed APIs that we have provided as part of the Windows Mobile 5.0 operating system, which you can really take advantage of if you're a managed developer. And one of the examples I'm going to show you is the use of the Windows Mobile status class library, by which you can find the status of some of the commonly used things very, very quickly. Say you want to write an application that needs to know what the status of the battery is at a particular time. You can pretty much write that code in one line. And you can go beyond that, and you can also receive notifications. So if your battery is going down below a certain level, you can get notified inside your code, and you can handle that. Or if you have an incoming call coming in, you can receive a notification and make your app behave in a slightly different manner. So let's write some little code that will allow me to now detect whether I'm cradled or uncradled. So the first step we'll do is to specify the reference for Microsoft Windows Mobile status. We just added the library. The second thing we're going to do here is going to use system state, which is one of the objects, and create an instance using something called the system property. System property has an enumeration of close to 150 different properties that you can use, something like I talked about. It also has information like, when is my next appointment? How many unread messages do I have? It's a huge, rich collection of properties, and it's fully enumerated. So if I remove this, let's go to the end of the line here. You can see all the different enumerations available. You don't have to remember them. As you scroll down this list, they're fairly intuitive and self-explanatory in terms of what each of them does. So let's use cradle present as one of the properties that I'm interested in. So I want to find out whether the app, when it's running, if the cradle is present or not present. The third thing we have to do, this is the step 3, is to actually handle the event. And again, for doing that, what we do, let me just write this here so you can see how the IntelliSense will actually work. So we set state of cradle, and we are interested in the changed event. It automatically completes my event handler. I can press tab. It also tells me, hey, you can call a particular function. It can create that for me, but I already have this one created right here, which is my code, and I'll walk you through what this code actually does. It's pretty straightforward. Let me uncomment this. So all I'm doing is, when I'm receiving that event, I'm finding out what the new value of that particular property is. And if it is 1, the SDK tells me it's cradled. If it's not, it's actually uncradled. So in literally 5 lines of code, I have now been able to figure out the status of my device. Now, this was a fairly simple example, but think of using this to a more complex environment as well. The code that is required to detect and do this is literally 5 lines of code. So now I press F5. I don't have a device here. This is one of my first presentations I'm actually doing where I don't have to carry a device because we're just going to show you everything can be done on the emulator. So I start the emulator. And notice how quickly it started. This is a change that we actually made after beta 2, where we implemented something called safe state, and Barry will talk more about that. But that gives you literally an instant start on the emulator now. You don't have to wait for the whole device to start booting up on that. You're in a predefined state, up and running in no time. So this time, my app is getting deployed, and here it is running. So that's part 1. We've completed the app. Now, what about the aspect of testing this? Now, how do I cradle an emulator? Now, to provide that, to manage that, we have a tool that we added called the Device Emulator Manager. This tool is aware of all the emulator images that are available on your particular device, and also knows which ones are running at any given point of time. All you have to do is come to this tool, right-click, say Cradle. I didn't connect a device. It just believed a device got connected to it. And you see, the form actually changed to Cradle. There was no other code I had in the form except to receive a notification. And I tested this exact scenario just by using the emulator now. This has been a huge significant change that we have made from the past emulation experiences that you have been used to. And Barry will definitely talk more about this in the rest of the talk. Let me cancel this, and let me disconnect and uncradle this so we know that we received the notification one more time. And so not cradle now. So you just tested using the emulator a very interesting scenario right here.
Okay. Can we pause for a moment to
yes,
take a question?
You have a question?
Is there a way for us to avoid that dialog box above screen?
I can follow up on that. In fact, somebody mentioned yesterday that they were doing it. So I don't know the exact way of, how we will be able to hide that. But yes, there's probably a way to suppress that. Because you can create a silent partnership, a silent guest partnership with any kind of a device. Yeah. And one thing to let you know that if you are doing any development with Visual Studio 5.0, you require ActiveSync 4.0. ActiveSync 4.0 is available for download as a developer preview pack, and it's also on the SDK kits that were available at our booth earlier today. Just one more question. Yeah. Yes, these libraries only work with Windows Mobile 5.0. Yeah, that's the first time they introduced managed support. And not just for the state and notification, all the Outlook libraries are also managed at this point. So if you want to get and do something with contacts, that's available too. So I have a few more slides before I hand things back to Barry. Jumped ahead on this slide so we can... Okay, so just to do a quick recap here, what I showed you was the ease of use in terms of how Visual Studio will make you very quickly into a device developer. You don't need to learn anything new here. And we have also been very sensitive about certain things that a developer really cares about. Support for multiple platforms. So Windows Mobile 2003, Windows Mobile 5.0, and CE 5.0, they're all supported. And I showed you how easily you can switch between them as required. We also support both Compact Framework 1.0 and 2.0. Again, this is something unique that our environment has been providing of being able to support 2 different runtimes at the same time. We also have a number of new device controls that are available to you, managed controls. I didn't cover them in detail, but there's a lot of information and talks available about new controls that are available on the MSD and Webcast site right now. Showed you the WYSIWYG Forms Designer with support for skins, orientation, rotation, everything happening at design time. Showed you a quick example of how a managed library is used. And that's, as somebody pointed out, it's only available in Windows Mobile 5.0. And a small, just 30-second overview of what the device emulator is, and showed you the device emulator manager. There are lots of things I unfortunately couldn't show you. If you're wondering what happened to C and native development for devices, yes, absolutely, it is there. In fact, we also added a feature to migrate all your EVC projects post Beta 2. So if you're using Beta 2, you'll not find it, but if you have the latest release candidate, we will now be able to migrate all your existing EVC projects as well. We also updated to the new compilers and native libraries as per the latest desktop standards. So all the security performance enhancements are now available on the devices as well. And of course, debugging is orders of magnitude faster. The native debugging was one of the areas where I know people have come and told me that I can go and make coffee while I step through the statements. So you'll have to find another time to make coffee because debugging is going to be really, really fast now on the native side. Another big thing to look forward to will be the SQL Server Mobile Edition 2005. That ships with Visual Studio 2005. And we have provided tons of good design time support for building databases now in this product. Remote tools is another thing people just asked for, especially if you're using Visual Studio 2003. We've added them to 2005 now. So you can start using the device remote tools. Lots of code snippets. So if you're kind of struggling with the basic things of, how do I get started? There are lots of code snippets in there as well that can help you. And to make sure that you have a complete kind of end-to-end story when you're a developer, we have now support for building CAB projects, setup projects, which are exactly the same way as how you would go about building a desktop project. So these are some things I couldn't touch upon, but there's plenty of information available on the MSDN side. Lots of webcasts. Most of the MEDC webcasts are available now, so you can go deep into any of them. Or if you have some questions, you can come by and ask me or somebody in the Windows Mobile Compact Framework team later today in terms of what the capabilities of some of these things are. So now that you're feeling a little comfortable about device development, let's go and spend some time understanding the new device emulator in a detail. And Barry, there's no better person than Barry to talk about this because he's been, creating that product for the last couple of years for us now. So over to Barry.
Okay. Thank you very much, Amit. For those of you who haven't had a chance to meet me out on the floor yet, emulators are my passion. I am tremendously fascinated by emulators, emulation technologies, virtual machines, and things. I'm passionate to the point where I've literally followed this code to the ends of the earth. Visual Studio for devices, the additions to Visual Studio, the target smart devices, recently relocated from Redmond headquarters of Microsoft to our India Development Center. So as part of that transition, I've actually transitioned to work for the India team to continue working on the device emulator. So my team is now half a world away from me. It's wonderful. So I have 3 stories to tell you about the device emulator. The first story is about fidelity and reliability. For those of you who've used the emulators that Microsoft has shipped in the past, these are 2 areas where we've been lacking. Also talk about program and data storage and how the emulator makes that much better for you. And I'll talk about the future of the emulator. It's tremendously interesting things coming up. So in previous projects, Embedded Visual C, Embedded Visual Basic, Visual Studio 2003, we shipped an emulator that emulated an x86 CEPC machine. The emulator was available only bundled with our development tools. You couldn't download it as a standalone product. You couldn't install it separately on your machine. It was an x86 emulator. Pocket PCs and smartphones run on ARM processors. So if you're a native code developer, you had to build for x86, test on the emulator, rebuild for ARM, test on a hardware device. Also, if you're an Embedded Visual C user, you're probably familiar with connectivity. It's very, very flaky. Never very fast and never as reliable as you would like. So to that end, Visual Studio set out to build a brand new emulator from scratch. It's called the Device Emulator. We built it ground up based on your feedback about the x86 emulator. So we laid down a series of design goals. Our primary target was user mode application developers, so Visual Studio users, Embedded Visual C users. We want to build apps for Windows CE, Pocket PC, and smartphone. They want to target an emulator because it's convenient to do, but they also want to know with a high degree of certainty that if you run on the emulator, you'll also run on a hardware device. Emulation is as fast as possible. We don't slow the emulator down to emulate a 200 megahertz machine. However fast your PC is, that's how fast the emulator goes. We also observed that applications are generally independent of hardware. So the device emulator emulates one specific ARM motherboard, but it's a good representative of all of the ARM devices that are on the market today. And connectivity was a critical thing for us to get right. It had to be fast. It had to be reliable. It had to work each and every time, thousands and millions of times in a row. Our secondary design goals were Windows CE developers who were rolling custom kernels for custom hardware. Those developers use Platform Builder. They do some application development, some driver development, and they have different needs. They want to talk to PC hardware like USB devices plugged into the PC, PCMCIA cards, things like that. So this is a little sort of head-to-head, the x86 emulator against the new device emulator. The x86 emulator runs a subset of the instructions from your PC. So if you have an Intel processor, you have an Intel emulator. If you have an AMD processor, you have an AMD emulator. It emulates the CEPC, which is basically a PC chassis. It has ISA slots, it has PCI slots, has a fairly straightforward video board, has a keyboard, it has a mouse, has audio, and a straightforward network adapter. The x86 emulator also sort of extends the notion of CEPC to include some extra features that are emulator specific. Folder sharing is one. You can take a directory tree on your Windows machine and mount it as a storage card into the emulator. And it has a resizable display. You want to have one emulator and sometimes run it at 320 by 240 and sometimes at 640 by 480. The device emulator, on the other hand, emulates an ARM 920 TDMI processor. That's an ARM processor. It supports thumb instructions, debugging, multimedia instruction set, and internetworking between ARM and thumb. The motherboard we chose is the Samsung SMDK 2410. It's a relatively interesting development board. You buy one from Samsung, it's got chips and wires hanging out of it. You wire your own power supply in. It's a really great board to mess with. It has on board a PCMCIA controller, 64 megabytes of NAND flash memory, has an LCD controller, a touch screen. We added to that an NE2000 PCMCIA network card. There's also an onboard CS8900 net card. So the device emulator can be multi-homed. It can have two network cards working at once. The emulator also supports a keyboard, 3 serial ports, and audio, both input and output. Like the x86 emulator did to CEPC, we took the Samsung board and we stretched it. We added a resizable display. We added what we call DMA, a direct memory access between Windows and the emulator. And we grew the RAM. The Samsung board has 64 megabytes of RAM. That's not enough for application development these days. So the emulator can stretch to 256 megabytes. We looked at the folder sharing code in the x86 emulator. We threw it out. We rewrote it ground up. It's much faster, much more reliable, works in many more places. The device emulator is also just a Windows process. The other emulator was based on virtual PC technology. Since the device emulator is just a Windows app, it actually runs on places like Win64. It runs inside the WoW64 subsystem. So it runs in more places. It does some more things. In terms of fidelity, our goal is to run ARM code with as much fidelity as possible. We've heard stories of people even writing managed code on Compact Framework where they build their application, deploy it onto the x86 emulator, everything works fine. They deploy the application onto a PDA, and the application doesn't run. Some simple things, a capacity limit inside NetCF that's different for the size of ARM code versus x86 code can make a tremendous difference. So we wanted to faithfully run the ARM instruction set. We support ARM and thumb and interop between the two. The ARM specification has a few implementation-defined areas. The device emulator follows the ARM 920 as much as possible. There's a few esoteric things we hope no one ever builds a dependency on. The device emulator emulates a hardware board down to the chips and registers. If you roll a Samsung SMDK 2410 image in Platform Builder, you can download it and boot it on the device emulator. And similarly, if you build for the device emulator, you can download and run on the Samsung board, but the emulator-specific features just won't light up. We had two really significant non-goals. Our most important is that we are not clock cycle accurate in the device emulator. We're much more interested in correct code fast rather than slowing down the emulator, burdening it with all of the housekeeping around clock cycles. ARM has some wonderful emulators, the ARMulator it's called, which supports cycle accurate emulation. It's very slow, between 5 and 100 times slower than the device emulator. Similarly, our peripheral device emulation is good enough to fool the Windows CE drivers into booting and running, but they aren't actual replications of things like the internals of the network card. So the timing can be different, and if you aren't running Windows CE on the emulator, it probably won't boot. So for reliability, Visual Studio for Devices introduces a new transport mechanism between Windows and the device, and also the emulator, called CoreCon. CoreCon provides us with one platform which lets us talk to either devices over ActiveSync, or devices over TCP/IP, or emulators through the emulator DMA interface. CoreCon has a bootstrap. The bootstrap basically sits on your Windows machine, and as you're beginning your deployment, the bootstrap gets pushed over onto the device or onto the emulator. In the case of the emulator, the bootstrap is actually the thing that launches the emulator for you. Once we're bootstrapped, we have a data transport. It moves data back and forth. It's a pipe arrangement with streams inside it. I think as we've pushed close to release candidate in Visual Studio, we've done things like single step millions of times in a single session as fast as we possibly can to make sure that this is absolutely rock solid code. The device emulator DMA is basically an interface that appears to Windows as a COM interface on the side of the device emulator, and it has some simple read a packet and write a packet COM interface methods. And those packets arrive inside CE as a special device driver. They're 4K fixed size packets, pretty straightforward system. And that's what allows us to deploy and download into a device emulator without having any network connectivity. For those of you who use Visual Studio 2005 Beta 2, we defaulted to communicating with the emulator over the network, and we introduced a patch that you could download that added a DMA transport. In Visual Studio, the release candidate in RTM, we're going to switch over, and that's now the default. For connectivity, ActiveSync was terribly important for us. We really wanted to have a good cradled ActiveSync experience. If you've used the x86 emulator in the past, there's this wonderful tool whose name I can't even pronounce, EMU-ASConfig. And you had to know things like the IP address of your Windows machine, and you sort of hacked to ActiveSync to connect to your device. If you didn't want to do that, you took a serial cable and you plugged it into 2 COM ports on your Windows machine. You pointed ActiveSync at one COM port and the emulator at the other COM port, and you sort of did a sync over 56K kind of thing. So we built an extension to ActiveSync as part of the device emulator that uses our DMA interface to allow us to ActiveSync at about 50 megabits per second. So far faster than USB, far faster than our Ethernet connection. And we built a virtual cradle, the device emulator manager. So you can cradle an emulator, you can use it, you can uncradle it, you can cradle another one. You can do guest partnerships, and you can do full partnerships. It's as first class a device as any hardware device as far as ActiveSync is concerned. The device emulator also uses a Windows kernel mode device driver called the virtual switch, which allows us to do Ethernet networking on your PC. Basically, it sits in the Windows network stack, and it lets us do packet injection. We can push a packet into the network stack, push it up into Windows, or we can push it into the stack, and we can send it out over the network card and broadcast it out over the Ethernet. Virtual switch has a number of sort of interesting limitations, and that's some of why we've backed away from it as the primary deployment mechanism. But we do make it available because it's very, very useful to be able to test your app over an Ethernet connection. So that's my first story, reliability and fidelity. Next I'll talk about program and data storage, what's new in the device emulator. As you know, devices have a fixed amount of RAM, usually 64 megabytes. And for developers, we tend to build our applications sort of larger than what we give to our customers. We build with unoptimized code, we build with assertions and logging and all those other kinds of things. It causes our binaries to swell up as we're developing. Testers also want to feed in worst-case data sets into your applications. They want to send big data sets in. And RAM contents, of course, are lost whenever you reset a device or an emulator. So To address those, we grew the device emulator up to support as much as 256 megabytes of RAM. You start with a base of 64 megabytes, and then in 1 meg increments, you can grow the memory size up to a total of 256. The device emulator also has 64 megabytes of flash memory. This is new. The x86 emulator never had this. We take a file on your Windows machine, 64 megabytes in length, and we poke it into Pocket PC and smartphone as if it was a 64 megabyte NAND flash chip. That memory then is persisted. You can exit the emulator, you can launch the emulator again, the flash contents are still there. It shows up as a storage card. We also use folder sharing, which takes the directory tree on your Windows machine and turns it into a virtual storage card inside the emulator. That gives you virtually unlimited storage. I've taken the entire source code to Windows and the entire source code to Visual Studio and poked them into File Explorer and Pocket PC. Works like a charm. So there's a little screenshot here. I'll show you more as the emulator is running. The File Explorer shows two directories. One is storage card, which is our folder share, and NAND flash, which is a 64 megabyte NAND flash. You can get at these things on the emulator command line. We have a command line option called shared folder, and we also have a flash file name to mount the flash card. At runtime, you can change many of the device emulator's configuration options. This is new. The x86 emulator didn't let you do this. You can add a storage card, you can remove a storage card, you can plug in the network card, you can unplug the network card while the emulator is running, while Pocket PC is running. Unfortunately, our flash memory is based on the Samsung board, and the flash is hardwired onto the board. We can't pull it out. We'll think about whether we do removable flash in a future version. So enough talk. Let's go and take a look at the device emulator. Let me find my Pocket PC 2003. Yep, excellent. This is Pocket PC 2003 running inside the device emulator.
You had one question?
Oh, I have a question. Yes.
You said that the device emulator could run in many places. Does that include Virtual PC?
Yes, the emulator runs inside Virtual PC.
All our labs are running that actually, so you can, it's there.
Yes. So the device emulator has the same skin that we saw in Visual Studio. The skin files that you use to design your forms are the exact same skins that are available to the device emulator. We can also turn off the skin, turn it on again at runtime. And go in Display, turn off the skin. Now we just have the bare bones emulator. If your screen real estate is tight, you can turn off the skin. And then you can turn it back on again by just re-clicking on the skin option. And the skin is back again. So we're going to just go to Start, Programs, and File Explorer. And when we go up to My Device, we see NAND flash. And this is the 64 megabytes of NAND flash that is mounted in this version of the device emulator. I can go in, do File Configure, and share a folder, like C:/demo. The screen will repaint with storage card. And that storage card is my C:/demo directory on my Windows machine. If I click on it, I can see my demos. Another question?
So are these installed by the SDK?
Visual Studio 2005 ships with Pocket PC and Smartphone 2003 second edition images. And you can download the Windows Mobile 5.0 SDKs, and those come with new emulator images. And they plug into Visual Studio seamlessly. Yes, that's correct. All the ones that show up in the manager are installed as part of the SDK. So that's Pocket PC 2003. There's a flash menu up here. And flash save is what takes the 64 megabytes of flash and saves it out as a Windows file so that you can use it later. So you can recycle those. You can move them around, copy them from machine to machine, whatever you'd like to do. So next I'm going to show you Windows Mobile 5.0. I'm going to launch it from a batch file. And I want to do this just so you can see how fast the emulator can come up. There it is. It's up and running. You just saw the screen repaint. What we've done there is implement basically what a device does for suspend to RAM and resume from RAM. We tell Pocket PC in the kernel that we'd like to suspend the device the same way would happen if you press the power button on the device. And once Pocket PC has gotten itself into a quiet state, we grab all of the emulated RAM and we put it in a disk file. When we want to launch the emulator again, we take that disk file, we load it back into emulated RAM, and we just resume where we left off. So this is exactly the same as what you do when you suspend and resume your Pocket PC PDA. The advantage to this, then, is that we don't have to wait for the entire operating system to boot every time you launch the emulator. Cold boot the emulator once, create a save state file, and then always boot from that save state file. That's one of our performance accelerations we introduced into the product after beta. Was it after beta 2?
This one after beta.
After
Save
beta,
state was after beta 2.
After beta 2. So after beta 2, all of the images that show up in Visual Studio and the device emulator manager automatically boot from the save state file. So you don't have to wait the 20 to 30 seconds for Pocket PC to boot if you want to use the emulator. So the emulator that I launched here is running Windows Mobile 5.0, and this is a high DPI image at 480 by 640 pixels. That's why it looks so large on the screen. Windows Mobile 5, this is also a phone edition of Windows Mobile 5. So I can do some fairly interesting things. I can go to No Unread Messages, and I'm going to send an SMS message, a text message. I have a wonderful phone number to send my message to. And I'll say, hello, PDC. I'll click send. So I just sent a text message from a device emulator. Now, where did this message go? This machine doesn't have a radio. So the message looped back through what's called fake RIL, which is a virtual radio that's built into the device emulator. And there's some special telephone numbers like 001, 0001, which say if you send a message, the message will come right back to you over that telephone number. So there's a message back from SMS. You can test SMS applications without sitting in a Faraday cage or without irritating your operator or spending dollars sending messages. I can also use the phone dialer. I can dial a number. I can click talk. We'll dial this number. And this number is hard-coded to report that it's busy. So you can test line busy, you can test data connections, you can test voice connections, you can send text messages, receive text messages, tremendous number of things you can do. So this is all built into the device emulator as part of both Pocket PC 2003 and Windows Mobile 5.0. Now, let's see if we can make this work. No. Apologies for this. Let's switch back to Pocket PC 2003 if I can for just a moment. The device emulator supports automatic rotation. So I'm going to press the soft key, which is hardwired to do a rotate of the device. The emulator switched over and Pocket PC switched over as well. Similarly, if code running inside the operating system wants to do a rotate of the display, the device emulator will automatically flip itself over to reorient and make the display stay vertical for you. So that's rotation. And we can go and mount a storage card one more time. We'll launch in Programs, PowerPoint Mobile. And PowerPoint Mobile went out, enumerated all of the PowerPoint files and all of the storage cards, and actually found our talk. And PowerPoint automatically rotates the emulator. And so here's our slide deck on Pocket PC Mobile on Windows Mobile 5.0. There's our talk inside an emulator.
We were actually wanting to do the whole talk from the emulator, but we realized that we'll probably not be able to capture it as effectively But this is one of the powerful capabilities. I showed it to a few people at the booth as well, including streaming Bill Gates' presentation that we watched on the emulator.
Yes, we managed to stream over ActiveSync the PDC talk from out on the internet into the device emulator and play it live inside Media Player 10. Fascinating project. Okay, well that wraps up this part of the demo, so I'm going to switch back over to slides for a few moments. On to the future of the device emulator. Version 1, as you know, of any product, all you're trying to do is just get it out the door. Finish it, ship it, get on with the interesting stuff in V2. So V2 of the emulator, we have a tremendous number of things that we're interested in doing. The slides are all in red. Of course, you know this means none of this is set in stone. These slides are plutonium. If you touch them, you'll probably explode. But I want to share with you sort of my vision of where the device emulator is going to go over the next couple of releases. As I said, Device Emulator V1 ships in Visual Studio 2005. It's just the beginning. We've only been working on it for 2.5 years, and it's basically a two-person project. So very small, very focused, building emulators. Now that we've got version 1 wrapped up and out the door, we're starting to look at what to do next. We're very interested in debugging features. We think we can do things on the emulator that can't be done on a hardware device or that are very hard to do on a hardware device. I'll talk more about that in a few moments. We want to do extensibility, expand the emulator out from a fixed function, emulate a single board with a single set of peripherals, stretch it out so that we can do new boards, new kinds of peripheral devices, new kinds of CPUs. We're thinking very hard about a very rich user interface. The skins that we showed today are okay, but they're a bit clunky. They just have push buttons and nothing else. And we're very interested in letting the emulator talk to peripherals plugged into your PC, USB disks and GPSs and things like that. Really, our goal for the next couple of releases is to help reduce time to market for devices and applications. We want to speed up your development cycle as much as possible. So you can use emulation in places where you would normally use devices. You can use more emulators. You can run many emulators on a PC. So they're cheaper, they're more expendable, they're just more convenient. So one of the things that I've been doing is looking at Platform Builder. Platform Builder is the development environment for Windows CE 5.0 and for building CE kernels. The CE and Platform Builder have a kernel debugger, which ordinarily requires a special debug build of CE or Pocket PC that has the kernel debugging turned on, and the debugger that runs on the Windows machine, and a wire that connects the two together. Ethernet or USB are the two most common ways. Platform Builder also has the ability to plug in a hardware debugger, an in-circuit emulator or an ICE, and debug a hardware board. Most ARM-based boards have a JTAG plug on them, which is basically a hardware debugger. Lets you touch the registers of the device directly. It lets you touch RAM directly with no cooperation from the operating system. So we said, could probably do one of those in the device emulator. So I sat down over a couple of days and built an EXDI plugin for Platform Builder. Lets you take a retail version of CE or Pocket PC or smartphone, boot it up in the device emulator, and then attach Platform Builder to it, break in, debug whatever you'd like to, and then disconnect and let things continue running again. And when I say debug whatever you'd like to, I mean it. You can debug the bootloader, you can debug interrupt handlers, you can even debug the kernel debugger itself. The device emulator's hardware debug interface is exactly like debugging on hardware. It has hardware breakpoints, hardware single step. Windows CE kernel never knows that there's anything going on. So let me give you a quick demonstration of what that looks like. Amit was kind enough to launch Windows CE 5.0 inside the device emulator. And we booted with a larger size screen, 640 by 480, to make Windows CE feel a little better. We also have Platform Builder running on this machine. And as I said, this is the sort of development cockpit for Windows CE. What I'm going to do is do a target attached device. We'll wait a minute for things to get organized. And this dialog comes up and says, what device emulator would you like to choose to connect to? I've configured Platform Builder to use the device emulators debugger instead of the built-in Platform Builder debugger. So now I can connect Platform Builder and the kernel debugger to this version of Windows CE that's running. Now CE is still running over here. If I click a little bit, the start menu will move. But I can switch over to Platform Builder, and I can hit the pause button and break in. And, probably for the first time at the PDC, we'll show ARM assembly code. We've broken into the kernel, and we've actually broken into the idle loop in the kernel. This BEQ instruction is the busy loop waiting for the next interrupt to come in inside the operating system. I can now single-step my way through the interrupt handler. This is code that you could never debug with the kernel debugger, because the kernel debugger depends on running interrupts. You'd recurse if you tried to single-step through this code. Now that I single-stepped a little bit, I can hit go. I can go back to the device emulator, and I can close the start menu. So that's hardware debugging. You just connect Platform Builder, you attach, and you go to work. And when you're done, you detach, you're back running again. Thank you. So one of the next things that we're interested in is extending the device emulator. In the interest of shipping version 1, we built a monolithic exe, deviceemulator.exe. It has one CPU emulator, one motherboard emulator, and the list of peripheral devices that more or less match the Samsung board that we cloned. But we're very interested in opening that up, turning things like interrupt controllers and video controllers into DLLs that the device emulator glues together to build an emulator that exactly matches the hardware configuration that you're interested in. You might have more serial ports or serial ports at different addresses. You might want a different kind of ARM chip. All sorts of things are possible. Device emulator is already constructed this way. We just have to expand out the exe from a monolith to a collection of DLLs. We're also very interested in layering some of the peripheral emulation. For example, today we emulate a Samsung serial port by connecting it to a Windows serial port. There's cases where it's interesting for things like test automation, where you might want to connect the ARM serial port to a Windows data file and pipe in the contents of the data file into the emulator as you test data. And we'd like to do that in more and more places. We'd like to be able to inject packets into the network stack. We'd like to inject keys into the key stack. The device emulator, it has a touch screen, not a mouse as its input. So we'd like to be able to inject touch data at very high resolution, 500 dpi or higher. We're also interested in doing virtual USB PCM CIA devices. We have one virtual device already, the NE2000 card. We'd like to do a virtual GPS so that you could test GPS functionality on a PC that doesn't have a GPS. You probably get a dialog and it'll ask you what coordinate would you like to, where would you like to be right now. And all of this really drives testability. There's many things on devices that are very, very hard to test today. You have to wait for your battery to die to test your battery going dead. You have to plug and unplug a device from a cradle to test cradling. With the device emulator, we have the option now of doing real test automation where we can programmatically control the emulator and tell it to do something. We could create a virtual battery and an interface on it that says the battery is now 10% charged or it's now 5% charged. And we can watch the operating system and the applications start to go through the low battery behaviors. Rich interfaces. Goodness, we have these little bitmaps that we show as skins. They're pretty interesting, but they're just rectangles and bitmaps. As we've now seen Windows Presentation Foundation and XAML and Sparkle and all of those things, we think we'd really like to do some rich controls. We'd like to be able to emulate a flip phone where you can open the clamshell and close it again, or show a multi-mon device where there's the main display on the inside of the clamshell and the viewfinder on the outside of the clamshell. All those things are possible with richer skins. We're not really sure the limits of what's possible at this point. We're just getting going and thinking about it. Direct access to PC hardware. We hear this a lot from the betas of Visual Studio 2005. People want to plug GPSs in. They want to plug cameras in. Windows Mobile 5.0 has APIs for GPS and cameras built in. That's the first time we've had standardized, consistent APIs. People want to use those. We want to plug in radios, make calls from your PC over the emulator. We want to see Wi-Fi devices like network cards plugged in. And because not everybody has a laptop with a PCMCIA adapter or USB, we want to be able to mix. We want to say we have a virtual USB controller, we have a physical GPS, and a virtual USB CD-ROM plugged in all at the same time. So we'll mix and match things. One of the toughest things we're going to have to deal with is security. We're going to have to decide, when the emulator has direct access to your USB memory stick, that means it can format your memory stick or it can copy the data off. We have to be very careful to think through those. That's going to add some complexity to the technology. So that's a fast tour of the device emulator. The device emulator is going to ship in Visual Studio 2005. We don't expect we're going to wait for the next version of Visual Studio. We're impatient. We have a lot to do. And so we're going to build a series of releases basically out of band from Visual Studio. We have a web download available now. We expect that we'll refresh that probably 3 or 4 times a year. And we're going to release it with new functionality as soon as it's ready. So if we have virtual USB, we'll put virtual USB up on the web for you. Unfortunately, these releases will be less supported than you're used to. These will be newsgroup support, which means you get to talk to me. In the future, we expect that we'll ship in Windows CE Platform Builder, in Visual Studio, and in the Pocket PC and smartphone adaptation kits. And those will be stable, fully supported, fully tested versions of the device emulator. That's that. Amit, back to you.
Thank you, Barry. Wow, this was very interesting. I mean, look at the kind of scenarios the device emulator is now going to open for you as a device developer when you are thinking of building mobile applications. The place where I've used this the most, I'll be very honest, I found a very interesting thing here. I go to Handango and different sites which have these cap files that are available. Now, because our emulator actually emulates ARM binaries, I can actually pick up the same file and without having to try it on my actual PC and Pocket PC and risk the fact that I don't know what it does, I just cradle my emulator to my PC, I install it on that, I play around with it, test it, I like it, I go buy it, otherwise I discard it. That's one good way of understanding what it means to having switched from an x86 based to an ARM based emulation. So next steps is installing a lot of software. So be patient when you go back, do the right things here. Visual Studio release candidate is the CD. I believe that was given out today, or it should be in your PDC goods. You would also require to download Windows Mobile 5.0 SDKs. Those SDKs don't ship inside of the Visual Studio CD, and there are free downloads that are available. The device emulator, if you just want to try the device emulator and the device emulator manager, which is the virtual syncing aspect, you can download the device emulator preview pack as well. And the links are available on the VST team blog. There's also a slide at the end. If you access the slide deck, you'll be able to get to the link. The good thing about downloading them standalone is you can even try them with EVC and VS 2003. So if you have a machine that's running EVC right now, you can actually cradle up an emulator and make EVC think it's actually talking to a device. So you can start using these emulators even with the existing products that you have. And of course, once you start using it, give us your feedback. A lot of team members in my group, spend time on the VST team blog and on the, getting feedback from the product feedback center. So don't hesitate to give us, information, feedback on what you think about these. So to wrap up, Visual Studio 2005 preserves your existing skills. So if you have been doing a lot of desktop development, you will see how easy it is to now move forward and do device development if you've never done device development before. And there's also numerous enhancements that we talked about, new designers, new controls, new managed libraries across the board, right from the design time features to changes in the runtime libraries to SQL Mobile to moving the entire embedded Visual C functionality and making it available in VS 2005. So changes across the board. And of course, we just spent the last 45 minutes learning about how the device emulator provides such a high ARM-based fidelity. So that's kind of my last slide, but something interesting that I want to show you before you go from here. So as I was showing this preview to a friend, a colleague in office, we were talking about the high fidelity of the ARM-based emulator. And he came up with something interesting. He says, you could probably emulate everything you want. You do sound, you can do video, you can capture USB disk. There's one thing you perhaps can never emulate. I'm like, what could that be? He says, that's a phone. Hit it really hard, it breaks. You probably can't do that. I'm like, okay. Maybe Barry can't figure that out. But I could do it. Now, guys, I'm telling you, product support services will not support you if you break the emulator. So try this at your own risk. So what you have to do is click your mouse really, really hard. It has to be hard. You can't do it, be soft on that. There I go. One more time. Thank you.
Thank you.
So we got some time for questions. Good, we finished up pretty much in time. So feel free. Yes.
With the 2003 emulator,
Yes.
the first time you run it, I think that you make some changes to the operation. You have to have an administrative privilege to run.
Sorry, what do you need to have there?
To have administrative privileges on that machine. You have to be an administrator.
No, you don't need to be an administrator to install or run the emulator. You did need to be for the beta, but not for the release candidate.
Yeah, I'm talking about 2003.
2003 required to install a driver. So for the first time, you had to be an emulator. Yeah. For Visual Studio 2005, there's a requirement that everything has to run as a normal user. And people who are leaving, if you can take 5 minutes to fill up the evaluation forms, that will really be helpful. Thank you.
Thank you.
And we'll continue with the questions. Maybe we'll move this side.
I had a question about licensing. Like, if we wanted to download the emulator for training purposes, can we put it on 10 training machines? Is that legal?
Not with the current license, but we're very interested in coming up with a license that would allow you to download the emulator for training.
Okay.
Absolutely.
Okay, we'll take one question this side and one question this side.
Can you talk a little bit about what you've done with the new SQL CE and what should be driving us toward that?
Okay, I can talk very briefly because that's not the area of focus of my team or Barry, unfortunately. We pick up SQL CE from the SQL Server group, and the part where my team actually gets involved is providing extremely rich designers. So in the previous versions, if you know, there was no design surface that was available. You had to write code for everything. At least from the Visual Studio side, what we have enabled is you can now work with data sources much like you work with the desktop data sources. You can drag and drop a table onto your form, and we'll make a grid or a layout, the way you have specified it. I can show you some scenarios. If we meet later, you can hit F5 on that. You don't even have to write a single line of code. We'll do all the hookups and binding with form load events and load and populate your data during relational databases. So there's across the board changes that have happened, including synchronization enhancements that have been made. But a lot of that comes from the SQL CE team, and we might have somebody here, who can give you more details on that. Yeah. Jenny, you could probably, she would be able to give you a lot of information. Yeah. Okay.
So the emulator's designed for a specific set of hardware and peripherals and everything.
That's
Most
correct.
people who are designing their own device using Platform Builder every single one's different.
Correct.
So who is that really useful for, the way it's designed right now?
It's designed for the Visual Studio developer who's building user mode applications. And so they're less concerned about exactly what peripheral devices are underneath them. They just want to know they can talk to a COM port or they can write on the display.
All right, and for people who are doing the Platform Builder, designing their own hardware, we'll just wait for the next version.
Hold your breath, and hopefully not too long we'll be able to build an emulator that matches your board description.
That would be wonderful.
Very much like to do that. Thank you.
Take one question.
I'm interested in using the camera and the GPS common API. You said that was something that would be supported in the future. How is it done now, and what would you recommend for debugging?
Right now, I believe the Windows Mobile 5.0 images are using the null camera driver, so you don't really have a camera available in the current emulator images.
Impossible to emulate that?
In version 1 of the emulator, we didn't have time to do camera and GPS, so we're very motivated to get that out as a web release as soon as we possibly can.
So I'll have to use my hardware in the meantime?
Yes, use your hardware in the meantime.
Same thing with the GPS?
Same with the GPS, yes.
I apologize if I missed this during the presentation, but when you were talking about the virtual phone and virtual SMS capabilities, is it possible for a server to, or your host operating system to send an SMS to the emulated device and for it to receive that message and process it?
Not through anything direct, unfortunately.
Okay. Is that functionality that you are considering, or?
I hadn't thought of it, but it definitely is something we could take into consideration.
Great. The use case is for an enterprise mobile framework where you're doing things like device management. Maybe you want to test, how the server would interact, like a notification framework, for example.
True.
And not to sound like a squeaky wheel, but we'd also love to see some sort of unit testing framework on mobile devices as well.
Great, yes.
Thank you.
Unit testing will be our, that's one of the areas we are focusing heavily for the next release. That from our team, we are spending a lot of cycles on that right now. So, yes.
Okay. Also something concerned with testing. Is there a way for UI for automated UI testing? A way to automatically press a button or to read a text box from the emulator?
Unfortunately, there's no good way to do that now. The emulator is a Windows app, and so you can sort of take screenshots of the emulator as a whole and send it keystrokes and mouse messages. But the emulator isn't aware of UI controls inside Pocket PC. It just sees this, a rectangle of bits that's the display. We are definitely thinking about automated unit testing that runs inside the device or inside the emulator for a future version of Visual Studio.
Thank you.
Yeah, kind of along those same lines, just the new team services, how much of those testing and all those new features are supported by the emulator?
Amit?
Actually, from the team's VSDS perspective, unit testing was one of the big features that we are going after. It's not there today, but you have new features like the creating class diagrams. Those are available at this point, but nothing very specific from device perspective.
Is there any way to use this technology with CE 4.2, either with Visual Studio 2003 or 2005?
Yes, you can use CE 4.2. If you choose the Samsung SMDK 2410 BSP, you build an image, it boots and runs on the device emulator.
Great.
Okay, so it looks like we are done, pretty much in time. Thank you very much once again, and hope you enjoyed the talk. We'll be at the Ask the Experts later today with other people from the Compact Framework Group and the Windows Mobile team. So if you have more questions, please feel free to come and ask. Thank you.